You ever just look around and realize that, well, everything is just a collection of shapes? I mean, think about it. Your room, your phone, everything. And the math to understand all of that isn't just for textbooks. It's actually a practical toolkit for measuring, building, and just making sense of the world we live in. So let me ask you, how do you measure your world? No, I mean really measure it. How do you know for sure if that new sofa you've been eyeing is actually going to fit against the wall? Or how much paint you need to buy to give a room a fresh look? These are totally normal, everyday questions, and they all have a mathematical answer. And it all comes down to this one cool concept, mensuration. It sounds a little fancy, but it's just the branch of math that's all about measurement. It gives us the power to figure out the length, the area, and even the volume of pretty much any shape you can think of. It's our ultimate problem-solving toolkit. So let's crack open that toolkit, shall we? We're going to start in the flat, two-dimensional world. Trust me, mastering perimeter and area is the foundation for absolutely everything that comes next. Okay, first things first. Two fundamental ideas, perimeter and area. And honestly, the easiest way to remember the difference is this. Think of the perimeter as the fence you'd build around a piece of land. The area, on the other hand, is the actual field inside that fence. So, one measures the boundary, and the other measures the surface it covers. Simple, right? And lucky for us, for all the common shapes, the ones you see everywhere, we have these essential building blocks. You can almost think of them as cheat codes. For rectangles, squares, triangles, and circles, these simple little equations are a starting point for figuring out their perimeter and area in a snap. But what happens when you run into shapes that aren't so simple? You know, those weird, irregular polygons? Well, the secret to solving them is both super powerful and, believe it or not, surprisingly simple. You just break them down into the basic shapes we already know how to handle.
Take a look at this polygon here. At first glance, it looks a bit tricky, doesn't it? There's no single, easy formula for a shape like this. It's kind of like a puzzle.
But watch this. What if we just draw a couple of lines? All of a sudden, that tricky polygon is revealed for what it really is. Just one simple rectangle and two triangles stuck together. We can find the area of each of those easy pieces, add them up, and boom, puzzle solved.
All right, now that we've got the flat world covered, it's time to take a leap into three-dimensional space. Now, in 3D, we're not talking about perimeter and area anymore. The big concepts here are surface area and volume.
And again, a simple analogy makes this crystal clear. Think of surface area as the wrapping paper you'd need to cover an object's entire outside. Volume, on the other hand, is the amount of space that object takes up. You can think of it as its capacity or how much stuff you could fit inside it.
So how do we even calculate surface area? Well, here's a really cool trick. If you could take a 3D cube and just unfold it, you'd get this flat shape called a net, which is made of 6 identical squares. The cube's total surface area is literally just the total area of this flat shape.
And this exact same principle works for a cylinder too. If you deconstruct it, you can see it's just 2 circles for the top and the bottom, and one big rectangle that's been wrapped around the middle. So you just find the area of those 3 flat pieces, add them all up, and there's your total surface area. Pretty neat, huh?
So here are the formulas that put all those ideas into action for us. For a cube, a cuboid, which is just a rectangular box, and a cylinder, these equations let us quickly figure out both the total wrapping paper, that's the surface area, and the capacity inside, which is the volume.
Okay, so we've built our toolkit for both 2D and 3D shapes. Now for the really fun part. Let's actually put these tools to work and solve a real-world problem. So here's the scenario. We've got an aquarium, which, let's be real, is just a cuboid, a rectangular box. And we want to decorate it by covering the base, both of the side faces, and the back face with some colored paper. The question is, exactly how much paper are we going to need?
Now, looking at our aquarium, we realize pretty quickly we don't actually need the total surface area, right? We're leaving the front open so we can see the fish, and we're leaving the top open. So we only need to calculate the area of a few specific faces, the bottom, the back, and the 2 sides. And here are our measurements. We've got a length of 80 centimeters, a width of 30 centimeters, and a height of 40 centimeters. That's everything we need to find our answer. Okay, let's tackle this one piece at a time. It's way easier that way. First up, the base area. That's length times width, which gives us 2,400 square centimeters. Next, the back face. That's length times height for another 3,200.
And finally, the two side faces. That'll be 2 times the width times the height, which adds another 2,400. Now, all that's left is to add it all up. So we add the area of the base, the back, and the 2 sides together, and we get a grand total of 8,000 square centimeters of colored paper. And that, right there, is mensuration in action.
And just like that, we've gone all the way from simple flat shapes to 3D objects, and we even solved a practical, real-world problem. You now have the fundamental tools of mensuration. So go ahead, take a look around you, your room, a book, a can of soup. They're all just shapes, waiting to be measured. So what are you going to measure first?